Hi there digital makers, and welcome to this week's Digital Making at Home from the Raspberry Pi Foundation. My name's Mark and here's my sidekick Jimmy.
Hello.
And what we're going to be looking at this week is the theme of robotics. So what I thought I'd do in this video today is I would show you how to build your very own little robot buggy. This is all called physical computing. It's where we're going to use a Raspberry Pi to interact with things in the real world. And if we have time, we might even try and make it controllable by Android device as well, yeah, on your phone. So we might give that a go as well. So let's get started with this. I'm just going to change screens here and show you some of the kit that I've got here. So here we go. So what I've got here is this. Jim, what's this?
A Raspberry Pi.
That is a Raspberry Pi. Right, let's see if you can guess the other ones. Let's have a look at what are these.
Motors.
Motors, well done. What's this?
Battery.
That's a battery pack. Tricky one now, you ready? What's this thing called?
Screwdriver.
Yep, a screwdriver, well done. This, but don't suppose you'll know what this is called, will you? This is what's called a, I'll just put it under the camera there. This is a ball cast. Yeah?
Okay.
Okay. And then finally, I've got two different varieties of what are called motor controller boards. All right. So this is a really cheap little motor controller board. You can find them on things like Amazon and AliExpress. This one's a little bit more expensive, but we're going to use this motor controller board today, which is made by a company called Fortronics. And the reason we're going to use this one is because this one can attach directly straight onto the GPIO pins of your Raspberry Pi. Okay, whereas this one, we'd have to do some wiring up. So we'd have to use lots of little wires to get to it. Okay, so I'm just going to put this one away. But this is the one we're going to use today. So the first thing Jimmy and I are going to do is we're going to wire up the Raspberry Pi to the motor controller, and wire up all the motors and all the power. Okay, is that all right? Right. This takes a little bit of dexterity. So let's see what we can do, Jim. All right. So let's do the fiddly bit. What the first thing we need to do is, because we're going to attach a hat to the Raspberry Pi. Yeah, these things are called hats when they just sit on the pins. We're going to have to power off our Raspberry Pi. Okay, so I've got the Raspberry Pi at the moment. It's linked up via what we call VNC. You'll notice on the Raspberry Pi, I don't have a keyboard and mouse plugged in, and I don't have a monitor plugged in. Instead, what I did earlier is I went to Preferences on the Raspberry Pi menu here. So I go to Preferences and Raspberry Pi Configuration. Okay, and what I've done is in the Interfaces tab, I've just enabled VNC. Okay, and then on my Windows laptop that I'm on at the moment, I've downloaded this thing called VNC Viewer, and because I know the IP address of the Raspberry Pi, that means I can remote connect to it. So we're just going to shut down our Raspberry Pi to start off with, so that we can attach that hat. Okay, so go shut down. All right, and you can see my VNC connection has disappeared. All right, so my Raspberry Pi is shut down. All right, so just pull the power out of the Raspberry Pi, that USB-C connector there. Go on. Good hard tug, excellent. So we always power off our Pis before we place hats on. So now you can place this hat on, so it goes this way round on those pins, yeah?
Okay.
Excellent, we just got to make sure those pins are all lined up properly. No, back a bit more. There we go, and push on. Push quite hard. Excellent. Yeah, brilliant. That's perfect. Now the fiddly bit. So now we've got to put all our motors and stuff in. Okay, so let's just turn this like this. Okay. All right. Now then, we've got these three little terminal blocks here. 1, 2, 3. The middle one is going to be for power. All right, and the other two are for the motors. And I don't care which wire goes into which slot, because we're going to show a little trick later on so we can control all that code. All right. So what you need to do is place one wire into there and another into there. Can you see if you can do that?
What?
So that's it, a little bit down. There we go. And then, yeah, that's perfect. Now screw it on. So in the top, that's it. And then righty-tighty. Righty-tighty. That's it. Until it's really firm down. Yeah. Does that feel about as low as it can go? Yeah?
Yeah.
Okay, let's just have I'll do a little tiny tug like that. Okay, then what I'm going to do is we're going to place the rest of the motors in. Okay, so we've put our motors in, yeah? And we've also wired up our battery pack to that central terminal.
Yeah.
Now, what will happen is when it doesn't matter which way around the motors go, yeah? It doesn't matter which wire we put in which for the motors, but for the battery pack it is important, okay? So the red wire is normally for what? You can take a guess, 50-50, positive or negative?
Positive.
Yeah,
Negative.
positive.
Oh, positive. Okay.
So that goes to V in, and V in will be labelled on your motor controller board somewhere, and the black goes to ground, okay? So that's important you get that the right way around. So now our motors are all set up. You'll notice, or you might be able to see on camera, that I've actually labelled the motors. So we've got an L on one, okay, and an R on the other. And now what we're going to do is we're going to do some coding. So what I need to do is I need to reconnect to the Raspberry Pi. Oh no, we need to power on the Raspberry Pi. So do you want to plug that into that USB-C port there? Okay. Brilliant. And then what I'm going to do is I'm going to wait for that to power up, and then we should be able to connect to it using VNC. Okay, so we have VNC loaded up, and Jimmy's going to drive the keyboard now. So if you want, Jimmy, can you go to the Raspberry Pi logo up at the top? That's it. And then just go to programming and then Mu. Mu doesn't come pre-installed on Raspberry Pi OS, but it is in the recommended software packages, so it's really easy to install. So the first thing we're going to do is we're going to import to the robot class from the GPIO0 module, yeah? That's it.
So
You'll notice that, that's it. You'll notice that Jimmy's using tab completion, which you've got in Mu, so you can press tab on certain keywords and it'll just auto-complete it for you. Good, so we've got our robot class. We need a name for our robot. What do you want to call it?
Rob.
Rob the robot. So Rob equals robot, that's it. And now we need to put in those pin numbers that the motor controller is connected to. Now for different motor controllers, the pins are going to be different numbers. The particular motor controller I've got here sitting on the Raspberry Pi, just move that over, I know that that one is connected to pins 7, 8, 9 and 10, okay, of the GPIO pins. But if you look at the documentation of the motor controller you've got, you'll be able to see what pins it's connected to. So let's get those pin numbers in. So in our robot we need to open, that's it, two sets of brackets, 7, 8. Those good, and we need a comma between those two sets of brackets, that's it. 9 and 10, good, perfect. And then hit enter, and the command is
Rob.forward.
good, and then open close brackets at the end of that. Right, and now if we run this now, go on, sorry, just save it as Rob the robot. You've already got the save thing there, so just overwrite that one. That's it. That was our test one. Good, so we're going to switch on our thing, so hit run. That's it. Okay then. So our motors are going, yeah? And they're going to keep going for a long time. In fact, they're going to keep going forever. Alright? So what we need to do is we need to put a stop command in there. Alright? So underneath rob.forward, go rob.stop. Open close brackets. Now what's the problem with this if we just run this now?
It'll go forward for like a second and then just stop.
Yeah, in fact you're probably not even going to get to see it go forward. So what can we do?
I can add in a wait.
Yeah, what do we call that in Python?
A sleep.
Good, so what do we have to do to get the sleep?
So is it from sleep import sleep?
Close, it's from time,
Oh, okay, right.
import sleep, and it's lowercase in this case. Good. Okay, and then we can put in a sleep for 5 seconds between rob.forward and rob.stop. That's it, yep. Good, let's run that and see whether that works. Oh, have I got the power on? So you run it first so we can make sure that Rob stopped. We can see that the program's running at the bottom. and now I can see the little chevrons. See those little chevrons in the bottom corner?
Yeah.
That means that the program's finished running. So if I turn this on now, okay, and now run the program again, so stop and run, and our motors are going 5 seconds. Right then, now we've got to figure out whether we've got these numbers, 7, 8, 9, 10 in the right order. Okay, so think about this. Here's my motors, and I've got the right and left I've labelled on them. All right then. Now, if these were sitting in a robot that's facing this way, facing the way the arrows are, which way do you think the L should move? Which direction should they spin? Should they spin
forward?
They should. If they spin forward, the wheels will be turning in that direction, won't they? Yeah, and the robot will go forward. So let's run the program again and see whether that motor is going forward. Is it?
It looks like it's going backwards.
It looks like it's going backwards. So let's have a play around with our code and see if we can fix that. So what I would do is, I'm not sure which one's which. I would change 7/8 to 8/7 and see whether that makes a difference. Perfect, and run again. They're going forwards now?
Yep.
Brilliant. Press stop. Okay, now, I didn't see which way the right one was going, so let's run it again. Both go in the right direction, yeah? Now we've got to check, though, whether we've got left and right correct. Okay, so stop the code. That's it, actually wait for... Stop and... that's it, good. Okay, so let's just check. So instead of rob.forward, type rob.left. Okay, brilliant. Now just let's think about this a second before we run it. If it's turning left, yeah, which way round should the left wheels go? If you wanted the robot to turn this way, what should happen to those left wheels?
You shouldn't move.
They might not move, and just the right one go forward. What else could we do to make it turn sharper, though?
Move those ones backwards.
So if on robot.left, L should move backwards.
Okay.
So let's run.
Yep.
Brilliant. Okay, and stop it.
Oh wait, you have to...
Oh yeah. It'll stop after 5 seconds. It's fine. So we've got that, our left motor and our right motor's correct. What we could have done, if they were the wrong way round, we just swap these tuples around. So we put that one over this side and this one over that side. Okay? Right, what we need to do now is we've got our basic robot. Okay? What we're going to do now is we're going to stop recording for a little bit, and we are going to use this box here, okay, that I've got. All right, I'm going to use this box to make my buggy. So what I'm going to do is inside the box, I'm going to place the motors, yeah, with the wheel, it's sticking out to the little axle sticking out, and I'm going to put some wheels on. Oh, I forgot to include wheels in our kit.
Should we record that start now?
No. What we'll do is I'll get some wheels out and I'll show everyone what it looks like. But yeah, you're also going to need some wheels for this project. Right, so let's stop recording for a bit and get this buggy built together, shall we?
Yeah.
Brilliant. All right, so Jimmy and I have now built the buggy. I'm going to show you what it looks like. So let's just switch over and have a look here. So what I've got is inside the box, I've put the 2 motors, and I've still got my Raspberry Pi and the little power pack there, and then the power lead still there. Okay, and then I push the axles of the motors through the side of the box on each side so that I've got wheels. And then you might be able to see in here, down here, I've just put in a bit of wire, and all that's doing is it's threading through holes in the box to make sure that the motor doesn't shift and move around. So that's just holding that end of the motor down in place. All right, because when the robot starts to move backwards, if that wasn't there, then the motors would just lift up. All right then. So should we go back to your code, Jim, and have a look at, so it's the 4th one now. That's it. And have a look at how this works on the robot. Now, I will say, if we were doing this for real, okay, it's a really rubbish prototype, isn't it? Yeah.
Yeah.
Okay, but it's going to work. If we were doing this for real, I'd be running the Raspberry Pi off a power pack rather than having it plugged in. But I can't find my power pack because I'm pretty sure Jimmy's lost it. So we're going to run it. It's still running off the mains, which means we're not going to be able to see the robot move around, but we'll still be able to see the wheels and everything move. So let's just place that like that. Okay then. So Jimmy, do you want to run your code and we'll be able to see the wheels turning? There we go. Get 5 seconds, and then it stops. All right then. So that's all working. Okay, and let's just run the code again and try and catch it before it falls off the table, okay? So I'm just going to lift this camera up a little bit higher so you can see that there. Right, you're going to run the code and then catch it. Let's move that back. There we go, and it's turning. Right, and that's good. Now the other thing I would normally do, let's just get that back there. The other thing I would normally do is I take this this caster here and I would attach it to the front of the robot. All right, but we're not, because so this is like a third wheel that sits at the front. Yeah, let me just take it out of this plastic. There we go. So this is like a third wheel and it'll sit at the front, and it means that your robot can turn. But as we're not going to be driving this one around, we're just going to be showing you how to code it. Then I'm not going to put that on at the moment. All right then. So we did talk really briefly saying we might try and make a remote control for the robot. So should we show everyone how to do that?
Yep.
Cool. So let's get onto our code. So what we're going to do is we're going to get rid of that. Brilliant. And then up underneath from time import sleep. In fact, we can get rid of from time import sleep now. We don't need that anymore.
Alright.
Okay, so we want from blue dot, all lowercase, and then import blue dot with a capital B and a capital D. Excellent. Okay, so blue dot is a Python library written by a very good friend of mine called Martin, who also works at the Raspberry Pi Foundation, and he has written this Python library, and he's also written an Android app that goes with it. I'm afraid it's not available on iPhones, it's Android only, this one. So I've installed the Blue Dot app from the Google Play Store. Just do a quick search for Blue Dot and you'll find it and install it onto your phone. And the other thing I've done is you might notice up in the top right hand corner of the screen there, that Bluetooth icon. You want to just give that a click. And what I've done is I've paired, if you look down at the bottom, there's my Android phone, okay, and it's paired. We don't need to connect to anything at the moment. Once I've paired it, yeah, Blue Dot will take care of the rest, so you can click off that. Right, so we need to set up our Blue Dot object. So BD equals Blue Dot, open brackets, close brackets. Capital, that's it.
Oh.
Open, close, excellent. And now what we're going to do is we're going to create a couple of functions. We're going to create a function called move, and that's going to handle the movement, and we're going to create a function called stop, which will make it all stop. Okay, so if you enter a couple of times, and we'll go def move, and then open some brackets straight after move and type in pos. And what's going to happen is the Blue Dot library is going to pass in this thing called pos, which is going to be your position on the screen of the Android app. Okay, so wherever your finger is, that's where pos will be. All right, so put a colon. You're going to yawn. Okay, and enter. Okay, so if pos dot top colon, so that's if our finger's at the top, enter. And then we want it to, so if our finger's at the top of the screen, which direction do we want to move it?
Forward, so
yeah,
Rob
so
dot forward.
Rob dot forward, brilliant. Okay, if the pos is at the bottom.
Should I just copy this?
Yeah, except you don't want to use an if, do you?
What do I want to use?
Else if, what's that in Python? elif, that's it. Elif pos dot bottom, enter. And then it's because you haven't put a colon at the end of your line. That's it. Brilliant. Rob dot backwards. Now you can copy and paste if you want. That's it. And then if it's right, we want if if the position is on the right, we want the robot to turn right. Oh, it's hot in here, isn't it?
Yeah.
It's a really sunny day in Lincolnshire today.
Why can't I not do that?
And then if it's left, then we want the robot to turn left. Brilliant, and hit enter. Okay, a couple of times. We like 2 line breaks between functions in Python. Yeah, don't have to, it's just like what we like to do. So we now do our stop function, def stop. Now we don't need to pass pos into this, so you can just open close brackets and put a colon. Enter. And then what you're going to command the robot to do. Have you changed your robot's name all of a sudden?
Right.
Yeah. Stop. Open brackets, close brackets. Okay, and hit enter a couple of times again. Brilliant. And now we're just going to set up so that blue dot runs those functions. Okay. So what we want to say is bd dot when underscore pressed equals move. So that means that whenever it's pressed, it's going to call the move function. bd dot when moved equals, and then we're going to pass it the move function again. So that's if your finger, say your finger starts off at the top and then you move it to the bottom, yeah, it would go from being going forward to going backwards. And lastly, bd dot when released equals stop. So when you lift your finger off the blue dot, it should stop. Okay then. So what we're going to do is run that. Yep. Now you can see down at the bottom it says server started, yeah? So what it's doing at the moment is it's waiting for blue dot to connect. So let's see if you can see on my Android phone. There we go. And what I'm looking for is, I'm looking for the oh no, wrong one. Let's do that again. I have to turn it the right way around so I can do this. I'm looking for Raspberry Pi on here, so I'll click Raspberry Pi. And there we can see that big blue dot. Okay, now this is going to get tricky. So what I'm going to do is I'm going to hold the camera up. Let's go up a little bit higher with the camera. There we go. And then there's our robot. So Jimmy, just do one little push at the top. Good. And our robot goes forward, push at the back. Brilliant. Left and right. Excellent. And there we have it. Really, really simple way of remote controlling your robot using blue dot. Okay. Well done. That was excellent work. Let's just go back up to that. So that's it for today. As I said, you can find this project at rpf.io/dm-buggy. And in there, there's also details how to get to a few other robot things, including how to do the blue dot code, how to remote control it with buttons, yeah, on a breadboard, how to remote control from another Raspberry Pi, and there's also a project on there to create a line following robot, so you can have one of these robots that follows a line on the ground. So thanks a lot, everyone, for listening to me and Jimmy today, and we shall see you all again in a couple of weeks' time, I should think. Don't forget, if you do make your own robot and you want to film it moving around and then put that on YouTube, you can send us a link to that. You can share your code with us. You can do all of that at rpf.io/home. Okay, thank you very much, and goodbye, everybody.
Bye.